everyone, let us start our session for today. Can you hear me?
Yeah, you're audible.
Yes, you're audible.
Okay. So, welcome to day two of our bootcamp. In today's session, we shall be studying about linked list and double linked list. And this is a quite easy concept to understand. Linked list and double linked list serve as building blocks for implementing more complex data structures like stacks and queues and graphs. As we'll be studying about them in our following sessions, we'll be implementing these data structures using the linked list data structure. And from today onwards, we'll be building out our codes which involve manipulation of data structures. So when it comes to linked list and double linked list, these are the following operations that we'll be studying. We'll be initializing a constructor for our linked list, then the append, the prepend, the get method, the insertion and removal method. And we'll be studying this for a linked list as well as double linked list. So almost all of the operations that revolve around linked lists simply involve manipulation of the pointers of the nodes that are used. So in yesterday's class, I think I gave a little brief overview of nodes and pointers. We'll be studying about this again today. So let's get right into it. Okay. So first of all, we shall be comparing a linked list to a simple list. So the thing with a simple list is all the elements of a simple list are arranged in a contiguous place in memory. Just a second. Somebody has their mic on. Can you turn it off, please? Kirti Chaudhary. Just a minute.
Kushi, you are muted. Kushi, hello.
Yeah.
Yeah.
Let's continue. So we were comparing our list to linked lists. So what I was saying is that in a list, all the elements are arranged in a contiguous place in memory. That means they are arranged right after the other, right one after the other. But when it comes to a linked list, they are all actually assigned in random memory places in your computer's memory space. And thanks to our pointers, we are able to get all of the elements in the perfect order whenever we are carrying out our traversal algorithms or anything on it. So yeah, one more thing about linked lists is the first element is called as the head and the last element is called as the tail. And when it comes to all the operations that we carry out, we'll also involve manipulation on changing the locations of the head and the tail of your linked list. So as I said, in a linked list, all the elements are arranged in random spaces in memory. But because of pointers, you can access any element in your linked list. But that's not the case with your regular arrays or your lists. Linked lists use memory very efficiently as they allocate memory only for the elements they contain. This contrasts with arrays, which often allocate memory for a fixed size contiguous block. And this can lead to wasted memory. For example, if you define a fixed size for your array, but you don't use it up, then you have wasted your memory space. And we are going to study about singly linked lists and doubly linked lists. So in a linked list, you will be having your pointers. One will be a next pointer. That's all in a singly linked list. But when it comes to a doubly linked list, you will be having a next pointer as well as a previous pointer. As you can see, just a minute. As you can see, this is a singly linked list where all of the elements are pointing to are using the next pointer to point to the next element in the linked list. But when we have a doubly linked list, you'll also find arrows that point to the previous nodes of your list. So in a doubly linked list, you can traverse in a bidirectional manner. And this allows us to access elements in both the directions. For example, if you want to search for elements or if you want to iterate the list in a reverse order, doubly linked list is very efficient. And doubly linked lists are commonly used in applications that require undo and redo functionality, such as in text editors or graphic design software. And each action performed by the users can be stored as a node in a doubly linked list, and it allows for efficient navigation through the history of all of the changes. Am I clear until here? Any doubts until now? That is a no. Let us continue then.
Okay, I understand.
Sorry?
Totally understand.
Okay, let us continue. So we introduced to the concept of singly linked list. Now we'll compare this linked list to a dictionary so that we can easily understand what exactly this concept does. So, for example, you have an already existing linked list and you added a node to it. So, what exactly is happening here? We could compare this concept to the concept of a nested dictionary, and you can call each and every single node, that is, every element of your linked list, a dictionary. And when it comes to making your entire linked list, all the elements of your linked list will be a nested dictionary. I'll show you that right now. So a node can be considered a dictionary which has one value and one next pointer. So these are the two parameters that are taken by a node. When we actually implement the linked list, we won't be implementing it as a dictionary, but a class. We're just comparing it to a dictionary so that we can easily understand this concept. So as you can see here, we have a value parameter and a next pointer. So when we take our entire linked list, it can be considered as a nested dictionary with every element, every next pointer pointing to the next dictionary. As you can see here, you can see our 7 pointer is pointing to this entire dictionary, and then our 23 pointer is pointing to this 7 dictionary, and so on and so on. And then this is how we initialize it. This is our first key of our linked list nested dictionary, which is called the head, and the last element is the tail. As you can see here, this is a good way to understand the concept of linked list. You can initialize a linked list in this way. And as you can see here, we have implemented this method. We'll be calling the next and the next pointer. And then we print out the value, which will be 23. Any doubts until here? Did you guys understand this?
I didn't understand. Can you just repeat one more time? Sorry.
Okay, so here essentially we compared our linked list to a nested dictionary, and every element of a linked list is a node. Now, node is not a primitive data structure. It's not integer type, character type. It's a derived type. And when we are actually going to carry out our operations on linked lists, we'll be initializing them in classes. But for now, for understanding the concept, we're comparing it to a dictionary. So every element of your linked list can be considered a dictionary. And as you can see here, do you remember the concept of dictionaries, right? You can have nested
Yes.
dictionaries as well. So it's
Yes.
like that. So you can
Okay.
say that, yeah, this is our head value. 11 is the head value. And in a linked list, as I said, there are pointers that point to the next element of a list. So the same way, you'll be having the head value, which is 11, and the next pointer will be pointing to the next dictionary here, and the same will be done until the tail of the list. And the last element of the linked list, that is the tail, points to none. This is the convention to declare your linked list. And so we tried to carry out some, so we tried to run our code using this statement here, this print head next dot next value. So we have our dictionary called as head, and we'll be iterating through the list using this method. Here we call the next, and then the next, and then the value. As you can see here, are you understanding? As we
Yes.
iterate through the dictionary, this nested dictionary, we point from the next pointer to the next, and then we finally reach the value 23. Any other doubt?
All right, got it. No.
Now we'll be
Ma'am,
initializing. Yes, yes.
in last slide, the key was next, right, and value, but
Just
we cannot have same keys, right?
where do you mean exactly? Here in this code?
Yeah, that key is value and next, right?
Yeah, are you trying to say that we can't declare it like that? We can't give the same
Yeah,
inputs.
no,
I'm
like the name of the key shouldn't be same, right?
I mean, I actually never heard anything like that. And if we are able to implement it, then I think it is possible to give the same names.
Okay,
Can able to implement this.
Sorry,
We can implement this.
we can implement list for linked list. Are you trying to compare linked list
No,
to
like
regular list?
we can have the keys with same name or something like that.
Yeah, I mean, I never heard anything like you can't assign the same name. This is my first time hearing it. And I think that since you can, in fact, call this method and everything, call this dictionary and get the value, I think it is possible, right?
okay, if it is
Do
possible,
you
that's fine
Yes.
because I have been told that the keys of a dictionary is a tuple, so a tuple cannot have a duplicate value. So if it is okay, then it's fine.
use of a dictionary? Okay. If you still have a doubt about it, you can text me. I will look into it further.
Okay,
As of my knowledge, I have never heard anything like this. So, yeah, we're going to initialize our linked list class, and we'll be building our linked list constructor. So as we all know, we have every class where every time we define a class, we define the init function which initializes your class, and the parameter that is taken in this init function will be the parameter taken by your class whenever you're making your own instance of the class. Everybody is clear with this, right?
Yes.
Okay. So, yeah, we'll be having various different operations. As I said earlier, we'll be having our append, prepend, get, insert, and remove methods. And all of these take the value parameter. They all have this in common. And each and every single one of these operations will be carrying out this same operation, that is creation of a new node. In the init function, we'll be creating a new node, in the append one as well, and in the prepend as well as the insert method as well. So the append method will create a new node, and it will take that node and add it to the end of the linked list. The prepend method will be creating the new node and add it to the beginning of the linked list. And the insert method will create a new node and insert it anywhere in the middle of the linked list. And the insert method takes in the index parameter as well. Rest all of them don't take the index parameter, only the insert method does it. So since all of these methods are going to be creating a new node, why not just implement a class that creates that allows you to create your own nodes, and then you can instead of making an entirely new class or a new function, you simply be building a new node object which will be calling this node class. Let's see here. So this is our node class. Just a second. This is our node class, and we'll be initializing our node class as well. It will be taking in self and value as its two parameters. And as I said, a node can be compared to a dictionary. One parameter will be value, another will be the next pointer. So when we initialize our node, we'll be giving in the parameter of self.value and self.next. So by default, whenever you're initializing a node, self.next will be pointing to none. And whenever we are carrying out our operations on this linked list, then we'll be manipulating the wherever this next parameter will be pointing to. We'll see it soon whenever we carry out our operations. So here we have our linked list class, we have our init function, and so the even our init function will simply create a new node. It will create its own instance of the node class. It will take the value parameter in, and as I said, a linked list has a head and a tail. So whenever you're initializing a linked list, initially it will only have one element in it. So the head and tail will be pointing to the same node. So this is how we'll be defining our constructor for our linked list. As you can see here, we initialized our first node, then we had our head and tail point to the new node, and we also initialized the length of our linked list to be equal to 1. And this is basically all we need to initialize our constructor. Now we'll be making our own instance of it, and we'll be constructing our own linked list. So if we run this, as you can see here, we initialized our own method, our own instance of this class, and then we decide to print the value of our linked list first element. So it shall be returning the value 4 to us in our console. As you can see here at the end. Yeah. If you have any doubts, just tell me in the between itself. I'll pause and I'll sort out your doubts. Any doubts until now? Yeah. Now we'll be going on to our next method, which will be the append method. So the append method essentially adds new elements to the end of the list. So as you can see here, you had a new node and you decided to add it to your linked list. So how do you do that? For that, first of all, you have to take in various parameters into consideration. For example, if you don't have any initialized linked list and you simply want to append the node to your linked list, for that you'll have to basically construct your linked list again. So initially our self.head and self.tail would be none. So what we'll do is we'll start pointing the head and tail to our new node, and this is how you'll initialize your first linked list. If the list is already empty, if there is no list to be started with, we'll see how the code looks like for it. We'll be first making our own instance of the.
సాయంకాలం 7:30 కల్లా
Just going to mute everyone. But I think if I mute everyone, I might end up muting myself as well. Let us continue. So as I said, whenever your linked list is empty, you will initialize your linked list by pointing your self.head to the new node, and you will be doing the same to the self.tail. So if self.head is none, this will be our code line. If the value of self.head is none, instantly we understand that the linked list is empty. There is no linked list to start with. So we'll be initializing our linked list by setting the self.head to be equal to the new node and the self.tail to be equal to the new node. So this is our first step. This is the condition that you will apply if your linked list is empty. If your linked list is not empty, you will have to carry out different operations. For that, take a proper look at this. This is our new node. This is our linked list. Now, initially, your new node is pointing to none. And as I said, when it comes to the operations that we carry out on a linked list, it involves basically manipulation of pointers. So what we'll do is simply we'll take the pointer of our new node and we'll assign it to be equal to self dot head. As you can see here, it will be equal to self dot head. We'll see what happens here. And then we'll be assigning the variable self dot head to be equal to our new node. Wait just a minute. I think this is the prepend method, not the append method. I'm so sorry. Just a minute. Yeah. First, we were talking about the append method. So if you want to append your new node at the end of the list, you can see that at the end of the linked list, the tail will be pointing to none. So if you want to append your new node to this linked list, you simply set the pointer of this tail node to be equal to the new node. And then you'll take this self.tail parameter, this variable, and you'll assign it to this new node. Let's see how we write our code. So as you can see, self.tail.next equals to new node. And then our self.tail will be equal to new node. And there you have it. You have appended your new node to your linked list. So this is basically how the append method works. Now we also have to increase the length of the list by one every single time we append a new node to our linked list. We'll be increasing the length of the list as well. And optionally, we'll be returning true as well in this method. When you're using this method alone, you wouldn't need to return true, but we'll be using this append as well as the prepend method to execute our insert node as well. You'll see it soon. And you will actually need to return true and false there. You'll see why we are returning true in this code in the next part. So we have our code and now we'll be running it in our VS Code. So in our case, we'll be initializing first first node with the value of 1 and another node with the value of 2. Just take a look at this code. Also, here you can see there is a print list function. Actually, I'm not explaining this function because in your HackerRank contest, it's going to be there. So don't look at this for now, just ignore it. And you will be able to implement it yourself when you're assigned your contest. So just take a look at your node class, your linked list class, your init function, your append function. Now, as you can see here, we created an instance of our linked list class. It's called my linked list, and we initialized it to the value of 1. Now we will be appending the value 2 to our linked list by calling this method on our object. And then we called the print list method to print out the value of the elements of the linked list. After we run this code, you have 1 and 2 printed out in the console. There you have it. Any doubts until now? I take that as a no. Now we'll be discussing the prepend method. So if you want to add an element to the beginning of your linked list, you'll simply manipulate the next pointer of your new node to point to the head variable of your linked list, and then you'll take your self.head and simply point it to the new node. As you can see here, we'll just point our next pointer of the new node to be equal to the head, and then you'll assign the variable to the new node. And even on the prepend method, we'll be considering the conditional if your linked list is actually empty. In that case, self.head and self.tail will be equal to our new node. So anyways, whenever we are initializing our prepend and append function, we'll always be creating an instance of the node class. We'll always be creating our new node based on the value that we add into it. So we have a new node, and if your linked list is empty, you simply point your self.head and self.tail to be equal to our new node. This will be the scenario if the length of the linked list is 0. So in this case, this is how we carry out this operation if your linked list is empty, as you can see here. Now, this was the case if your linked list was empty, and if your linked list is not empty, as we have already discussed, we'll simply be taking our new node next pointer and we'll be pointing it to our self.head node. Then we'll take self.head and point it to the new node. This is all you need to do. And then after that, we'll always be increasing the length of the linked list and you'll be returning true as well by the end. Let's take a look at this code and understand it for some time, and we'll continue from here. Now we'll be running our code in VS Code. So we'll be initializing our linked list. First, we'll be adding the value 2 to it. For the first instance that we create of our linked list, will be having the first node to be equal to 2. Then you append 3 to it. And then we'll be uh, calling the prepend method on our linked list object and then see what happens. Since we called the prepend method, uh, your first element will become 1 instead of 2. And this is how our code has successfully run and your prepend operation has been executed. Just take a look at the code. If any doubts, you can ask me. We'll continue. Okay, so we discussed.
List function.
So I actually am not going to explain the print list function. I just said some time ago. In the hackathon contest that you'll be getting by the end of the bootcamp, there is a question that asks about the print list function, and I would like you to carry it out yourself. And you can initialize it yourself as well. If you want to see it, go ahead. Just a minute. Yeah, this is the print list method. You can look at it, but I would actually like it if you guys try to do this yourself. It's not that difficult, and by the end, when you understand these concepts, you will be able to implement it yourself. If you want to look at it, take a look at it.
Thank you.
Okay. So we have carried out our append operation, our prepend operation, and we'll be using this append and prepend and another method, that is the get method, on our insertion method. So let's take a look at what this get method does. So the get method will be taking in the index as its parameter, and it will essentially return the node of which index you have been given. For example, if you pass in your function the value of 1, if you want the element that is located at index 1, your get method will be returning value 3 to you. If you say 0, then it will be returning 11, and so on, based on the index parameter that has been passed to it. So um, maybe whenever the user is giving their input, they might be giving an out of bounds value as their index. For example, if they give the index as -1 or any value that is less than 0, or if they give the index value as a number that is greater than the length of your linked list, then you'll have to um, uh, handle this particular conditional statement as well. So in this case scenario, we'll be returning nothing because we don't have anything going on in these particular index values. This will be out of bounds, so you won't be returning anything. Now, if you want to get the value of an element at a specific location, there are many methods to carry out a method. So in our particular scenario, we'll be assigning temp to be equal to self dot head, and then after that, let's take a look at this. We have our temp equal to the self dot head, and then after we have initialized our temp variable, we'll be iterating through the list until we find out the element at that list. And how does the loop know when to stop? It will stop at the specific index value wherever our element is located. So as we know, index starts from 0, and so does the for loop. If you want an element at the index of 2, it will first temp will first check this index, then this index, and then it will finally reach this index, and it will return the value. And to change the value of our temp, we'll simply manipulate its next pointer again. So temp's next pointer will keep on changing to the next element as you iterate through this for loop. Take a look at this. So we'll simply assign the value of temp to be equal to temp.next. Now you might be wondering, why did we write the code line as for underscore in range index instead of for I in range index. You can write it like that, but for readability, we have instead use underscore. You can use I if you were actually having any use of this parameter, but since we don't have any use of it, we'll simply be using for underscore in range index to declare our function. So it will iterate through your list, and then it will be returning the temp, returning the node, basically. This is our entire code. As you can see, take a proper look at it. We handled this specific condition where the index passed is out of bounds. And then we considered our regular case scenario as well. So let us run our code in the VS Code. As you can see, you have made your own instance. Linked list from this linked list class is first initialized to 0, and then you append 1, 2, and 3 to it. And then you called your get function on this object. Now you passed the index to be 2. So since the value at index 0 will be 0, at index 1 it will be 1, and index 2 it will be 2. Now you can see that the way it has been printed out is this unrecognizable line. I will explain what it exactly is. So if you want to get the value of your node, we'll simply tell our function to return temp.value, as you can see here, and then you'll get the value of 2. So what we saw right now, this is actually Python's way of representing an object in memory. As you can see here, this main.node object This indicates that the object belongs to the node class defined in the main module, which is typically the module where the code is executed. And this 0x, whatever you see, this is actually the memory address where the object is stored in hexadecimal notation. This is actually the concept that you study in computer organization and architecture. We don't need to dig deeper into this. I just gave an overview of this. So this is how Python represents an object in memory, basically. So since node is not a primitive data type, this is the reason why it returned the value like this instead of giving the value of the node. So if you want the value of the node, you simply have to return temp.value as we did here. Okay, so this was our get method. Any doubts until now? We'll be moving on to our I'm sorry.
जावा का यूज करके आप क्या
Python.
क्या काम
Okay. Let's continue with our insertion operation. So we studied append and prepend methods where you can add elements to the beginning or the ending of the linked list. And now we shall be studying about how to insert elements anywhere in the middle of the linked list. So we'll be taking various conditions into consideration here. Again, we'll be considering the out of bounds condition here. For example, if the index is less than 0 or if the index is less greater than the length of the linked list, you will be returning false. Now, remember how in our prepend and append method, we used to return true. This is the reason why we used to return true because you will be returning false over here. So if you want to implement your method properly, you'll also have to write a conditional statement where you return the true statement as well. So if you want to, for example, you called your insert method. And as you know, this insert method will be taking in the index as its parameter and the value as its parameter. So if you pass it index as 0, we already have a method declared for it, right? If we want to append, if we want to add our node in the beginning of the list, we already have our prepend method for that. So if index is equal to 0, that is the head, we'll simply return our prepend function on our particular instance. And similar would be the case if you want to insert the node at the end of the list. So this is the reason why we initialized our prepend and append methods to have an ease of writing out our codes for our insertion method. As you can see, if the index is equal to self.length, we'll be calling our append function on our linked list. So we we considered these three conditionals. Now we'll be considering the part where you have to insert your elements somewhere in the middle of the linked list. For example, you have a new node, value is 4, and you have to insert it somewhere in the middle of the list. For example, if you want to assign it to the index 2. So let us see what we'll have to do here. So we will be initializing a temp variable, and that temp variable is going to be using the get method to return the node at index less than one less than what your node is declaring. I'll show you the code. For example, you want your new node to be at index 2. So your temp variable will be using the get method to return the node at index 1, which is 2 minus 1. You see the code, you'll understand it using the code. So we have a new node instantiated. And then you have your temp variable, which will be equal to self.get index minus 1. Index minus 1 because you want your new node to be at the value 2. So we will be assigning a temp variable at the index 1 less than the index of where we want our new node to be. Let's see what should be our next steps. So we've initialized it until now. Now, we studied about prepend and append. I would like to ask you guys to give your own answers of how we will be manipulating the pointers of our temp and our new node to carry out this insertion procedure. Does anybody have an idea of what we'll be exactly doing? Any suggestions? You can give your answers in the chat box, or you can turn your mic on and speak. I'll wait for 2 minutes.
Can you repeat the question once?
Yeah, the question was, as you studied the prepend and append method, now we'll be studying about the insert method. You already saw what we do in the prepend and append method. You simply manipulate the next pointer of your new node and your tail or your head node. So I want you guys to think a little and tell me what could we do in our insert method. How should we be manipulating the pointers of the temp node or the new node as well, so that we'll be able to successfully execute this insertion operation? How should we manipulate the pointers of our nodes, of our temp variable, of our new node? So, okay, Sarthak said new node dot next equals to temp dot next and temp dot next equals to new node. New node dot next equals to temp dot next and temp dot next equals to new node. Okay. Any other answers?
Okay. Any particular exam post because learning everything the group of method.
Did somebody just give an answer?
ಈ ವೆಹಿಕಲ್ 15 16 17 ನಾನು election rumors.
Aditya, if you are trying to answer, your voice is actually muffled.
Let me
Sorry.
just. Okay.
Does somebody else have any answers?
Uh, yeah, like in the prepend, if I'm not wrong, we were assigning the head to a new node and tail to a new node, right? So and now with the inclusion of temp, like how we used what do you call we used the get method, right, to get to assign temp as
Yeah.
self dot head. So for
No, no,
adding
self.
the
Yeah. Okay,
right,
continue.
right, yeah. So
Are you talking about prepend or insert? You said temp equal to self dot head. In which method are you talking that? Because in our
no,
insert method, and
no, that was for retrieving the data, basically for getting the data. Like I remember we had a get function which is self comma get self comma index. I mean, it takes two parameters, self value and the index value, right? So
yeah,
and then you use, and the indexing is basically the length of the self parameter that you have, right? So like to add the value, uh like right now your question was like what will be the code for adding a value, right, to the given
yeah,
set
or
of code.
even you can give just, you can simply tell how exactly we'll be manipulating this. Where do you want your temp variable to point and where do you want your new node to point? How exactly we'll be manipulating it? You can see this is our temp variable, this is our entire node. This is
Right.
the next pointer of our temp variable.
Yep.
You can see it's pointing to the 23 node. And
Yes.
this is our new node, and its next pointer is pointing to none.
To none.
Now we will
Right.
be, yeah, we'll be taking this into consideration. So do you have any idea of what we can do?
Actually.
Okay, let's continue. Actually, we're running quite short on time. So essentially, we'll be taking the next parameter, next pointer of a new node and pointing it to the node which comes right after our temp node. So which it is called as temp.next. As you can see, new node.next equals to temp.next. And then we'll be taking the next pointer of our temp variable to be equal to our new node. Simple. So Sarthak's answer was correct. Very good, Sarthak. So this is our entire code, and as usual, we'll be increasing the length and we'll be returning true. So this is our entire code. Just take a look at it. Now we'll be running our code in VS Code. As you can see, this is what we'll be carrying out. We initialized our linked list. First element is 0, then you append 2 to it, and now we'll be carrying out our insertion. As you saw before, we wanted a linked list which will be having elements 0, 1, and 2. So for that, we'll be passing our insert function on our linked list object. So we'll be passing it the index and the value of our node. So we want our linked list to insert a node having value 1 at index 1. So 0, 1, 2. Is that clear?
Yes, ma'am.
Let's continue to our last operation for linked list, which will be the remove operation. And in our remove operation, we'll be taking in the index as the input parameter. We won't be taking value as the parameter. So here we have our linked list. Again, we'll be taking our out of bound conditional index less than 0, index greater than length. And in our case, in the case of returning the value, we'll be returning none. We won't return false or true, anything like that, since we'll be removing our element, right? If there is no element to remove, you won't return false, you will return none instead, because there is no element in those locations. So we handled our first condition. Now, in this course, where I've taken this content from, they actually define pop first and pop methods on their own, but you don't have to do that. If you want to remove element from the index value 0, you can simply define your pop and you can pass it index value as 0. So we'll simply write pop, and in this parentheses you will pass the value of 0, and it will be carrying out the same function as the pop first method. So if you want to delete an element from the first index equal to 0, you'll simply return the self dot pop 0 method on your linked list. And if the element that you have to delete is at the ending of the list, so if the length is -1, is self dot length -1, you'll be returning the pop method. Let's take a look at the code again, as you saw here. Let's take a look at this code. As you can see, if index is equal to self dot length -1, you can see you have our linked list. Its length is 3, and if the no, the length is 4. If you want to delete an element from the last, then you will be simply returning the pop method. Now, if you want to remove your element from somewhere in the middle of the linked list, again, we'll be assigning a temp variable to a particular node in our linked list, and you'll again be manipulating the next pointers of your nodes. And in this scenario, we'll be um, declaring a previous variable and a temp variable, as you can see here, and then you'll be deleting the temp. So Like how we did in our insert method, our temp was going to be equal to the index minus one of the index where you want to add your new node. Similarly, we'll be having our previous variable, which will be getting the index at the value of minus one of which index we want to delete, as you can see here. Then temp will be pointing to, I believe yeah, so it will be right after the previous dot next. You don't have to write self dot get index. We'll simply say temp equal to previous dot next. So these are our first two lines. Now, again, this would be very easy to do. Can anybody tell me what exactly will we be doing to remove this 23 node from our linked list? Can anybody send a code or give an answer?
Temp dot next is equals to prev dot next.
Temp dot temp dot next is equal to previous dot next. Okay. Any other answers? Previous dot next equals to temp dot next. Temp dot next equal to none. Yeah, this part is definitely correct. That temp dot next will be assigned to none. And previous dot next will be assigned to temp dot next. But the order of how we carry out the code also matters. So firstly, we'll be taking our previous variable. This is our node. And the next pointer of your previous is pointing to this temp, as we had already defined temp to be equal to previous dot next. Now we want to change this previous dot next pointer to point from temp to this temp dot next node, as you can see here, from here to here. So we'll simply assign previous dot next equal to temp dot next. Is this the answer that you gave, Aditya? I think this is exactly what you said, right?
Yes.
Okay, correct. And then we'll simply assign temp dot next to be equal to none. Adil also gave the correct answer. But first you will be assigning previous dot next to be equal to temp dot next, and then temp dot next will be equal to none. Otherwise, your code wouldn't run properly. Just keep this in mind as well. And as we are deleting an element, you will be decreasing the length of your linked list by one, and then we'll be returning the node that we have deleted to test if our function is running properly or not. So in our particular instance, we had a linked list and we deleted a method from it. We'll see it here. As you can see, we have a linked list. Then we use previous dot next equal to previous dot next dot next. Just a minute. Previous dot next equal to I think we can, but I'm not sure because it might throw errors. I'm not sure. You'll have to try to run it. You want to see it. Actually, we can't execute all of this right now because we don't have a lot of time. If you want, I will be sending the pseudocodes anyways, and you'll be defining your own codes. You can carry this out. I'm not sure if this would work properly or not. I mean, what you're saying, I understand. Previous dot next will be equal to previous dot next, and then previous dot next equal to none. It might work, but for the simplicity of our code for readability, we'll simply call it as temp. I think that's the reason why we declared our temp variable in the first place. If you want, at the end of the session, you can wait and we'll try to run this code in our console and we'll see if it works. Okay. So as you can see, we have initialized our linked list. First element is 11, then we appended 3, and then 23, and then 7. And then we decided to remove the value at the index of 2, which means the third element of our linked list, that is 23. So let's run this and let's see what happens. As you can see, it has returned our temp over here. And since this is how our node object will be called, you can see over here that we have returned the node. And if you want to just find out if your code is working successfully, you can return temp.value just for your sake of testing. But when it comes to the proper ultimate code, it wouldn't be taking in it wouldn't be returning temp.value, it will be returning temp because we want our entire node to be gone. We don't just want the value parameter to be gone, we want our next parameter to be gone as well. Is everything clear until now? So this was it for singly linked list. Now we shall start studying doubly linked list. Yeah. Okay, so as I have mentioned before, in a singly linked list, you'll be having two parameters, that is the value and the next. And in a doubly linked list, since you can iterate through both of the iterate in both of the directions, it will be doing so because of another pointer, which is the previous pointer. So we'll be having our self dot value, self dot next, and it will be having an additional previous pointer as well. So everything else is the same, just we'll be having an extra pointer for a doubly linked list. So let us initialize our doubly linked list as well. We'll define our init function. We'll make an instance of our node class, as you can see here. And your new node will be having a previous pointer, which will be pointing to none, and it will be pointing next also equal to none. And whenever you're initializing a linked list first, since the list is empty, Aditya Kumar is saying this is working. Okay. Okay, Sarthak, you have answered to your question. Okay, so whenever we're initializing our linked list, we'll be pointing the head and the tail to the same node which we are initializing, and the length will be at first 1. So let us run our constructor for doubly linked list. We'll be having our new node with the value of 7. It will be having a previous pointer which points to none, and a next pointer which also points to none. You can cut this code. As you can see over here, after we run our code, we'll simply be returning the value of 7 here. Okay, so this was our constructor for doubly linked list. Now, so similarly, how we carried out append, prepend, get an insertion and removal operation on our singly linked list, we now have to do the same for our doubly linked list as well. So now we'll be carrying out our append function on our doubly linked list. When we had a single linked list, we simply had just one pointer, the next pointer. So we simply had to consider this next pointer when we were carrying out our append operation. But when it comes to doubly linked list, you also have to consider this previous pointer as well. So let's see how we will be manipulating the next and the previous pointer. So as you just saw, we had our tail dot next to be equal to this new node, and this new node dot previous to be equal to self dot tail, and tail will be equal to our new node. Now again, if your linked list is empty, self dot head and self dot tail will be equal to our new node. Nothing new on that. So if self dot head is none, self dot head and self dot tail equal to new node. Else, if we want to add a new node, to an already existing linked list. As I said, self.tail.next pointer will start pointing to this new node, and our new node's previous pointer will start pointing to the self.tail node. And then we'll simply assign the self.tail variable to this last node, this new node. This was our append method, and as usual, increase the length and return true. Now let us take our code and run it. We'll see what happens. We had our linked list with the value of 1 initialized in our constructor, and then we appended the value 2 to it. So when we run our code, we'll be getting 1 and 2 returned. Okay, so we studied our append method. Now let's get on to our prepend method. I think now everybody must be getting the hang of how these operations happen. So similarly for our prepend method, if your linked list is firstly empty, you'll have self.head and self.tail point to none. And if that's not the case, then you'll simply, let me just rewind, you'll simply take the next node of your new node and point it to self.head. And then you'll take the previous node of your self.head and point it to new node dot next. And new node dot previous will be equal to none anyways, and then you'll assign self dot head to be equal to our new node. So now we're covering the part where if your list is empty, then we'll be simply assigning head and tail to the new node. Else, as I said, new node dot next equals to self dot head, and self dot head dot previous will be equal to new node dot next. No, actually new node, not new node dot next, just new node. And self dot head equal to new node. By default, when we say that self dot head dot previous is equal to new node, then easily it's understood that new node dot next will be equal to self dot head, as we've already done it here. Yeah. And new node dot previous is anyway equal to none, and our self dot head variable has been assigned to our new node. And as usual, increase the length and return true. Now we'll be running our code. We have our linked list. We had 2 and 3. Now we'll be prepending 1 to it. As you can see, we had our first element equal to 2. Then you appended 3 to it, and now you'll be prepending 1 to it. Okay, there you go. Okay, so this was our prepend function. Now we'll be getting on to defining the get function for our doubly linked list. So our get function for doubly linked list will be mostly the same as it was for our singly linked list, but we can take advantage of the fact that a doubly linked list can iterate in both directions to reduce our time complexity. As we see, we consider this out of bounds condition, then we assign this temp equal to self dot head, then you have your for loop that iterates through the index and it keeps pointing to the next node until you get your required, and it returns the temp node. All of this was done in linked list, and if we want to optimize our function for making use of taking advantage of the fact that you can iterate through both of the directions in a linked list, you can change your code like this. For example, if the element that you want to find out is in the first half of the list, as you can see, if it is at index 1, then you can simply iterate through it one by one. But what if you want to find out, what if you want to return a node that is from the second half of the list? In this case, you can simply go to the tail node and you can iterate backwards. You can simply point to the previous node and then you can return your temp node. It would be easier for us this way. Am I clear until now? Is everything being understood? Any doubts until now? I'll take that as a no. Anyways, so we'll be adding another if conditional to this for loop that we had already defined. And this for loop will run if the index length is less than half of the length of your linked list, as I discussed. If your required node lies in the first half of the linked list, then this code will be run, which iterates through the list to point to the next element of the linked list. Now, if that's not the case, then you'll be running an else conditional, and our else conditional will be doing something else. We'll be traversing in a reverse direction if the required node lies in the second half of the list. Let's see. So instead of initializing temp equal to self dot head in our else conditional, we'll be changing the value of temp to be equal to self dot tail. As you can see here, our temp will be equal to self dot tail. And then what we'll do is we'll be having our for loop. Now just take a look at it. As you can see, it will be starting from self dot length minus 1, which means the last element of the linked list. And then the last index where it will have to reach is the index of 0. No, not index of 0, the required index. And it will be decreasing by 1. All of you must have learned about this concept in Python and OOPS, right? We know about how to traverse through a list in reverse order. We have learned all of this. I don't think there's any confusion on this part, right? Okay, let's
No.
continue. Okay, let's continue. So we'll be assigning temp to be equal to self.tail in this particular condition. And then we'll be iterating in a reverse direction. And in this case, we'll be saying temp equal to temp dot previous. As you can see here, this is how you will keep on going behind. And now, as you can see, our 23 lies in the second half of the linked list. So you will be easily able to return your temp variable with less time complexity. So this is how we optimized our code to make it more efficient by taking advantage of the fact that our double linked list can traverse in both the directions. Take a look at this code again. It might be a little confusing to read. Just look at it again. We have our out of bounds conditional, we have our temp variable initialization, we have our if condition that runs this for loop if the element is in the first half. Then you have our else conditional that runs that runs in a reverse direction if your required a node is in the second half of the list. And we'll be returning the temp value as well. So this is our get method for our doubly linked list. Now we appended values to it. Now we'll be getting specific values from our list. As you can see, we'll be getting the index, getting the node at index 1 and index 2. So after we run this code, as you can see, we'll be getting 1 and 2. It will be returning the value of our node. Any confusion until now? We're almost done. We have reached our get method. Now we'll be discussing the insert and removal method, and then we'll be done. Any doubts until here?
No, ma'am.
Okay. Now,
No doubts.
as I asked everyone to give their ideas on what would happen in insertion for singly linked list, I would like to ask the same question for a doubly linked list. Okay, wait, somebody has a question. The difference that I'm completely will be less because of less number of steps taken. Yeah, definitely. That I'm pretty sure that is the reason why. And also, it's for the ease of readability as well. I think we will have to study more about the concept of time complexity to answer this question. Just send me this question. I will answer this question later on, Margana. Okay, let's continue. So If we want to add a node to the beginning of the list, we had our prepend method defined. If we want to add it at the end, we had our append method defined. Now I want to see what would happen if you want to insert a node somewhere in the middle of your linked list. We'll again consider this out of bounds conditional. If index is equal to 0, we'll return self.prepend. If index is equal to self.length, then we will be returning the self.append function. Now I want to see what would we be doing if we want to append this new node somewhere in the middle of our linked list. What would we do? Does somebody have any ideas?
Uh, I will take this the third one as the third, that means the index one as the temp node, and then I will take the temp dot next is equals to new node previous,
Okay.
and then new node next is equals to next the temp next previous.
Yeah. You can just type your code and send it in the chat box, and then we can see if it's correct or not. We will take two temps. Okay,
Okay.
Margana says we will take two temps. Anybody else has any answers? Okay. I guess there are no answers until now. Let's see what happens then. We want to insert this new node into somewhere in our linked list. So for that, we'll first have an after and a before variable. Now, maybe as Aditya said, his method could also work. You can implement the same method by different lines of code. It doesn't make a difference. If the one code is efficient, another code is not, we can take those parameters into consideration and decide which method is working the best. So in my explanation, we will be taking in two different variables. One will be the before and the after. So before will be the self.get index minus one variable, and after will be simply before dot next. We'll send an answer before dot next equals to new node. If just a second, I'll check it. So we have after equal to before dot next. So we are stretching it out for ease of readability. So what we will be doing, as you can see, before has a next pointer and after has a previous pointer. We will be taking these pointers and the pointers of our new node into consideration when we are carrying out our insertion operation. So what we will be doing is taking before dot next and we'll be assigning it to our new node, and we will be taking after dot next after dot previous, and it will be assigned to new node. Then new node dot previous will be equal to before, and new node dot next will be equal to after. Let's see a visual of it. As you can see here, you just saw right now. As you can see, before dot next equals to new node, after dot previous equals to new node dot previous equals to before, and new node dot next equals to after. Let's see how the code looks. As I said, new node dot previous equal to before, new node dot next equals to after, then before dot next equals to new node, and after dot previous equals to new node. This is really simple. We simply manipulated our next and previous pointers throughout linked list and singly linked list, and we carried out all these operations with so much ease. And use as usual, increase the length and return true. So now we'll be having our own custom insert method declared. So we have our linked list having element 1 and 3, and we'll be inserting 2 somewhere in the middle of the node. So as you can see, take a look at this code. Now we initialized our doubly linked list with the first value to be equal to 1, and then you appended 3 to it, and then we decided to insert the value 2 into it. So for that, you will be assigning it the index as well. So as you can see here at index 1, we want to insert a new node called which will be having the value 2. So after we run our code, we'll see 1, 2, and 3 has been printed out. So this is our new doubly linked list. Okay, let's look at these answer. This answer is a little incomplete. Before dot next equal to new node dot previous. Adil, did you understand the code? New node dot next. Did you understand how to exactly declare it? New node dot next equals to after dot previous. And Marvana has said temp1, temp2. Okay. Yeah, Margana's answer is almost correct. I think it's a little incomplete. Just one line of code is missing. You said, understood the loose ends in my answer. No, your answer is mostly correct actually. Temp1 dot next equal to new node 3. So instead of before and after, you had a temp1 and temp2. Before will be your temp1 and after will be your temp2. So you said that temp1 dot next equal to new node, and then you said new node dot previous equal to temp1, which is correct. And then you said temp2 dot previous equal to new node. Just one line was needed, and that is new node dot next equals to temp2. Did you understand, Margana? Just one, yeah, new node dot next equal to temp2. Perfect. So we are done with our insertion method as well, and now we're moving on to our last method, which is the remove method. So again, a remove method, instead of taking a value of the node as the parameter, it would be taking index as its parameter. And again, if the index is out of bound, we will be handling this condition by returning none, as you can see with these lines of code. Now, if you want to remove the node from the beginning, we will be having our self dot, here it is given as pop first. You can simply say self dot pop, and in parentheses, you can pass 0. And it'll simply run in the same way. If the index is equal to 0, we'll be popping element from the head of the list. And if you want to delete an element from the end of the list, you'll be simply calling your pop function. Now, if we want to remove any element from somewhere in the middle of our linked list, we will be again having a temp variable. And okay, here also I would like to get answers from you guys. I'll wait for 2 minutes just to give your answers. What do you guys think will be happening?
To remove the temp.
Mhm.
Okay.
Adil has sent a code before dot. Um, you declared before dot next. But you didn't declare first. You didn't declare before and after. You simply started to point your before and after nodes to this temp next temp dot previous. But first you'll have to declare your before and after variable to be equal to a specific node because you are actually carrying out this pointer manipulation on your before and after before even declaring your before and after variables. So I think this might throw you an error. So before you carry out these lines, Adhil, just declare your before and after variable.
I'm not
Okay,
able to use the meeting chat, but I'll just tell like what I'm thinking. It's like first, obviously, like temp is already defined as the index, right? So, like as you said before, we have to mention it as previous method we have to use, and after we have to use the next method for the temp itself,
yeah.
and then the before value would be equal to after, and the after value will be none, but the after previous will be equal to before, and
Sorry,
again before will
before,
be equal to none, right?
what did you say? Before will be equal to?
Before of next value will be after, and after will be equal to none, right?
But what will be your before and after variables be declared as? What will be the value of before?
Your before
You
would
simply,
be a temp previous. Temp is basically the index
okay,
value, right? So
yeah,
temp
okay, okay, continue.
so the previous one and the after one, and then I'll define before and after, and then after that, using the next method, let's say I'll just say like how exactly like how Satya wrote it, like before next is equal to after. I would just add another line that after is equal to none, so that it can remove the value of 23.
After is equal to none.
Yes, to
So,
remove the value.
yours, so okay, see, in our case, 23 is the node that we need to remove. So you're saying temp will be this 23 node, right? We'll be declaring temp to be equal to this 23 node. And before will be
Exactly.
this 3 node, and after will be this 7 node. So you're
Right.
saying after will be equal to none.
Mm, no, wait. I think I got it mixed up. Uh, you do you need to use none though? No,
It's
you
okay.
don't need to use none. Leave it. You can just use actually before next, and then you can define it as after. Yeah, that was wrong. You don't need to use none.
It's okay. It's okay.
Yeah.
If you can take your time, collect your thoughts, and just
Before dot
don't
next is
immediately tell
equals
your
to
answer.
temp dot next.
Before dot next is equal to temp dot next. Okay, okay, okay. Go ahead.
Then again,
Okay.
temp uh, temp dot previous is equals to before dot next. Sorry.
Previous is equal to before. Simply before. No need to say before dot next.
After dot
What?
previous is equals to temp before dot.
Uh, Aditya, you're not able to use the chat.
No, actually, I'm not able to use this chart.
Why is it?
I don't know.
Okay. Yeah, because if you wrote down the code and simply sent it, it will be easier for you to understand, right? It must be confusing for you to explain it like this. Okay, continue. Continue. You were saying you were going correctly. Continue, Aditya.
Actually, what I'm saying is before dot next is equals to temp dot next,
Okay.
and then again after dot previous is equals to before dot next.
After dot previous is equal to before dot next. No, no. I think that's wrong. You can say after dot previous is equal to
Temp dot previous.
temp dot previous. Yeah. I am not exactly sure if it would be correct or not, but from what I'm hearing, I think it might work. I would like to, I would suggest you that try to run your own code as well, whatever you have suggested, and I'll be showing you what I'll be suggesting as well. So as you guys
Okay.
said, we'll be declaring a temp variable, a before variable, after variable. We can do it like this. You can simply declare temp.previous and temp.next to be equal to none. Then before.next will be equal to this temp.next and after.previous will be equal to this temp.previous. This is one method to do it and it's quite simple. But we can do it with another method as well. Let's take a look at it. So we'll be initializing our temp variable and we'll be adding it to our code block and then just stretch it out for ease of readability. You can see all of these pointers here. You have to manipulate them in order to carry out our removal operation. So as you saw, we don't even need to declare a before and after variable. Simply make changes in the pointer of this temp variable and this. Just a second, we'll take a look at this. As you can see here, what we'll do is instead of declaring a before and after, we simply declare our manipulation on this temp variable. So let me run this visual again. You can take this temp dot next dot previous to be equal to temp dot previous, as you can see here. Did you understand? Let's take a look at this again. Temp dot next, you can see it here, should be temp dot next, which is our 7 node, and you can simply take the previous pointer of this 7 node to be equal to this node. And this node is nothing but temp dot previous. Am I clear? Are you guys understanding? Until now, is it clear? If somebody has a doubt, just raise their hand. I think I might be clear. Okay, so this was our first step. Now we'll
Ma'am,
be, yeah,
if we use temp dot next dot previous, then we also have to use on the RHS temp dot previous dot next.
yes, we are
Otherwise,
going to do that. We aren't done yet. We aren't done yet.
okay.
So as we did with our previous line, and now we will be taking in temp dot next. Let me run this visual again. Temp dot previous dot next will be equal to temp dot next. Am I clear? As you can see, temp dot previous, which is
Yes,
our 3
yes,
node. Yeah, and this 3 node is pointing to this temp. We want to take this next pointer of our 3 node and point it to this 7 node, which is nothing but temp dot next. After we're done with this, our pointers will be pointing out like this. And now we can simply write temp dot next and temp dot prev is equal to none. So in this way, we can carry out removal without declaring another before and after variable as well. And self.length will be decreased by 1 and will be returning the remove node. So this is our code. Take a look at it. Now we'll be having our custom operation done. So here you can see our double linked list. We'll be removing this one from this middle of the linked list. So we first initialize our linked list with the value 0, 1, and 2. Now we shall be deleting 1 from our double linked list and we'll be returning temp. As you can see, it has returned this node object. This is how Python returns the memory address. If you want to find out if your code is successful, you simply return temp.value. And there you go. You have to remove your remove the first value, remove value 1 from your double linked list. Am I clear until now?